Okay, so today we're going to be going over 5.1, solving inequalities by addition and subtraction. Okay, so right here, but now we're going to solve linear inequalities by using addition, and we're going to solve linear inequalities by using subtraction. Now, what this is kind of like setting limits. It's saying like, you can do this up to this point, but then you can't go over, or you can't go less than. So here's the key concept. 1. Solve inequalities by addition. Now, a lot of times, a lot of people struggle in reading these. And I want you guys to know that this right here is less than. This one right here is greater than. And these two right here, this one's less than, but also is or equal to. This one's greater than or equal to. It's kind of like emojis, guys. Just got to memorize what those mean. So, the addition property of inequalities, it says if the same number is added to each side of a true inequality, the resulting inequality is also true. Okay, in words, that's so difficult, right, to understand. So they use symbols. For all numbers A, B, and C, the following are true. So they're saying if A, there's that symbol, greater than B, then A plus C is greater than B plus C. Now, why is that? Well, we're saying if A is bigger, right? If A is bigger than B, for right here, where it says it, right? If A is bigger than B, it's common sense. That means if A plus C is also going to be bigger than B plus C, because we're adding it to the same thing. Alright? So if A is less than B, then A plus C has to be less than B plus C. You can also use this for if it's greater than or equal to or less than or equal to. Alright, so here we go. All I need to do is solve. So these are the problems you're going to get. It's the same thing, except instead of an equal to, I have now the greater than or equal to, greater than, less than, or less than or equal to. But the concept is the same. What do we want to get by ourselves? The x. So the opposite of negative 12 is plus 12. Whatever I do to one side, I do to the other. And now I get x. These cancel. X is greater than or equal to 20. Alright, and when I check it, 20 minus 12 equals 8. Is 8 greater than or equal to 8? Yes, it is. Some of you are going to say, but it's not greater than. It's saying it's greater than or it's equal to. And in this case, 8 is equal to 8. So, here's 1a. I have 22 greater than. Again, it's just greater than, not equal to, just greater than. Alright? So I'm going to add 8, whatever I do to one side, I do to the other. 30, bring this down, is greater than, cancels m. There it is. Or I could say m, if I read it backwards, m is less than 30. One or the other. It doesn't matter to me. If you want to write it proper, you could switch it. Look at this one. Greater than or equal to. Okay, let's see. I'm going to add 14. Add 14 because I want to get the d by itself. Cancels. D is greater than or equal to negative 19 plus 14. Well, let's see. 19 minus 4 is 5. The bigger number is negative, so it's going to be negative 5. Alright. That's all we're doing, guys. Now that we did adding, what do you think's next? Well, it's going to be subtraction. The problem is, though, before we go to subtraction, they're going to have a thing called set builder notation. So what is set builder notation, though? Set builder notation is we're saying, what variable are we going to use? So in this case, we're using x. And we use this notation to separate x is greater than or equal to 20. Notice again that they just use brackets. So it's brackets, what variable I'm using, and then I actually put my notation down. Alright. all it's saying is that x is what? If I were to graph it, notice that the circle is closed. Why is the dot closed? Well, because it has the equal to. It can be 20. Alright, so since it can be 20, I fill it in, and all the numbers that are greater than 20. That's saying that, hey, any number works as long as it's equal to 20 or greater. So now subtraction is saying, if A is bigger than B, well then that means A minus C has to be what? Bigger than B minus C. If A is less than B, that means A minus C has to be less than B minus C. And this works also for the same properties. Now, let's see these examples. Ooh, notice the answers are in set builder notation. So here's what's going to happen. I'm going to solve. I'm going to subtract 19. I get M is greater than 56 minus 19 is 37. Okay, which one is like that? Well, not that one. This one is not that. Oh, no, this one, see, the symbols are different. Not that one. So it has to be C, and we're using variable M, and here's the actual notation. Now, if I were to graph this, I'd go to a dot. Now, notice, ooh, the dot, I was filling it in. I shouldn't be doing that. See how this is just a greater than? It's not an equal to, so I would go 37, an open dot, and then all the numbers that are bigger than 37. Why is it an open dot? Because all the options can be 37, but they have to be greater than. It doesn't say it's equal to. It can't be exactly 37, only bigger than 37. So here's some practice. Alright, this one right here, let's see. What am I going to do? Well, I'm going to subtract 8. Ready to do one side, do the other. P is less than or equal to 10. So which one? That one, no. That one looks good. That one, no. That one, no. So it has to be B in set builder notation, or G in set builder notation. Okay. Now what happens if I have the variables on both sides? Same thing, guys. We already did this with equals. Now it's just with inequalities. So look, I'm going to want all the A's on one side. So what am I going to do? Subtract 3A. Subtract 3A. Cancel. I get 6 less than or equal to 4 minus 3 is A. So see that? See how it's reversed? So let's reverse it. Let's put A and see how it's big there. So I need big underneath greater than or equal to 6. Now, notice how they wrote it in set builder. They said we're using variable A, and its A is greater than or equal to 6. And how do I graph it? C6. Notice it's a filled circle. Why? Because it has the equal to. And anything greater than 6, and it goes on forever. Okay, let's see. Let's try this one. I'm going to add 1 to both sides. Okay, ooh, I'm going to change that. I noticed I could do it easier. Let's just subtract 9n from both sides. Alright, cancel. Negative 1 is less than 1n. Let's rewrite that. N is greater than negative 1. Now how would I graph that? Well, I'm going to put a negative 1, negative 2, and 0. So, am I going to have an open or closed circle? I'm going to have an open circle because it doesn't have the equal to. So here's my closed circle on negative 1. I mean open circle on negative 1. And it says it's greater than. So it needs to be bigger. So I'm going to go to the right. All the numbers that are bigger than negative 1. Now look at this one. I'm going to move the 4h. I'm going to subtract 4h from both sides. 5 minus 4 is h. Bring this down. 12. And it cancels. Oh, I'm done. Look, h is less than or equal to 12. So how do I graph that? I'm going to go 12, 13, and 11. Okay, is it going to have an open or closed circle? Well, it has the equal to, so it's going to be closed. And it's less than, so all the numbers that are less than 12. Okay, now right here is a good thing to get into your notes. It's just the emojis of how you read it. All right? Remember, less than, greater than, less than or equal to, greater than or equal to. Now, real world example. Felipe needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees. That means it has to be 82 at least, minimum. Currently, the basking spot is 62.5 degrees Fahrenheit. How much warmer does the basking spot need to be? So right now, if he needs it to be 82 degrees, right, and he has it at 62.5 degrees, he needs to add how much to get it at 82? Well, let me erase that and make it a little bit neater. All right. Or I can use the book. So look, 62.5 degrees plus how much makes it at least 82 degrees. Now again, it has to be minimum 82. So notice that they use the symbol greater than or equal to. Why? Well, because the smallest amount that basking spot can be for that leopard gecko, for the gecko, is 82. It can't be anything below that. If it's anything below that, they're saying it's bad. So that's why they set up the equation 62.5 plus t has to be greater than or at least equal to 82. So how to do that? I subtract 62.5. Those cancels, and I get t is greater than or equal to 19.5. So we're saying Felipe needs to raise the temperature of the basket pot 19.5 degrees or more. Why do they put or more? Well, the reason he puts or more is because it's okay if it's more than 82 degrees. It just has to be at least 82. So it could make it 83, 84, 85. So that's what we're saying. He needs to add 19.5 degrees or more. So look at this one. Sanjay has $65 to spend at the mall. So let's just write that. $65. He bought a t-shirt for 18 and a belt for 14. Okay, so 18 and 14, that's 32, just to have it there. If Sanjay wants a pair of jeans, how much can he spend? So we're going to put S for spend plus 32 has to be less than or equal to 65. Now notice I put less than or equal to. Why? Well, because he can't spend more, right? He won't have enough money. So I need to find out how much money does he have to spend so that he doesn't at least run out or he has money left over. So I'm going to subtract 32. S is less than or equal to 23. So that means Sanjay has to spend at least less than or equal to $23. No more, but he could spend less. If he finds a deal for a pair of pants for $10, that's fine. He still has money. Okay? That's all we're trying to do. We're trying to figure out what is the minimum or maximum of something. That is what inequalities are. All right? Here are practice problems. All right? But right now in class, I have a worksheet for you. I want you to finish that worksheet. Okay? I want you to finish that worksheet. If you have any questions, make sure to see me.